Welcome, everybody. This is Scott Schweitzer from SmartNICs today. Today I've got Alex Stein with me from Liquid Market Solutions. Alex, why don't you introduce yourself, give us a little background on who you are and how you came to start Liquid Market Solutions.
Hey, Scott. Good afternoon, and thank you for having me. This is one of those interesting questions, Scott. I'm a firm believer that anyone who tells you I am where I am because I came on a straight path either is a liar or hasn't done anything interesting in their life. And I think I've done some interesting things. So let me tell you how it comes together. And there were some definitely hard right and hard left turns. I started as a chip guy working on the world's fastest CPUs at Digital Equipment, explaining my gray hair for those of you who can't see my picture right now. From DEC, at that time, we used FPGAs. FPGAs were instrumental in aspects of our work as a prototype device. And when I get to the end of the path, we'll talk about why LMS is so focused on FPGAs, because they're a lot more than prototype devices. But from Digital Equipment, I had the opportunity to co-found 4 different internet fintech infrastructure startups. And that was a lot of fun and a great learning experience. My career started working on the best chips in the world, and yet that company no longer exists because they thought the best technology was all you needed, and they didn't respect the need for a business plan and a solid marketing and sales team. And that was a really visceral lesson for me, seeing this technology I loved go for naught. So from DEC, I ended up working on these 4 internet startups. I had the first internet broker-dealer funded by D.E. Shaw. I co-founded that, and that was really a lot of fun. From there, went to some pure infrastructure plays with Gomez. And after my 4th startup, I was working with the folks at 2 Sigma. They were actually interested in investing in a company that I was looking at. And they ultimately said, Alex, we have a much better idea for you. We want you to come to 2 Sigma to build Alpha Capture the 2 Sigma way, the systematic, quantitative way. And it'll be just like doing a startup, but you won't have to do all the crap that any entrepreneur knows. And anyone who's been an entrepreneur knows that from 8 a.m. to 8 p.m., you're working on stuff that no one cares about but must be done. You're paying your taxes, you're paying your bills, you're dealing with the lawyers and the accountants so that you can stay up late at night and be innovative. And I have to say, after doing 4 startups and being leadership or CEO in each of them, that was an incredibly compelling message for me. So the 2 Sigma guys said, come in, build Alpha Capture, we'll do all of that crap work for you. And I'm very pleased to say over 14 years at 2 Sigma, we really invented some unique approaches to Alpha Capture. One of the things to illustrate how different we were, when I would talk to outsiders about what we were doing, they would ask about, tell me about your Alpha Capture. And I would ask a question. I wouldn't just respond. And the question was, are you familiar with Alpha Capture? And they'd say yes or no. And the reason I'd ask that question and I'd explain it is, if they said they were familiar with Alpha Capture, I'd need twice as much time to explain the unique aspects of what we were doing. And this is an example of something that later in this discussion we'll talk about with respect to SmartNICs. Alpha Capture is a term everyone has heard, but it isn't a defined term that everyone agrees on what it means. And so it's really important to get underneath the covers and understand what you're really talking about. For our Alpha Capture, it was done in a unique, systematic way. I love that. And as part of that program, virtually everyone in the world wanted to cover 2 Sigma, all of the brokers. And so we got incredible exposure to all the global banks, to the regional, to the boutique, and we met a lot of really interesting people. And one of the most interesting people I met, and I should also say the most customer centric, was my current co-founder and our CEO at LMS, Seth Friedman. At the time, he was at Morgan Stanley, and then he moved to Nomura. We continued to work with him throughout. And I mentioned FPGAs a few minutes ago. In those discussions, late at night around the proverbial dining room table in our house, when we were coming up with the business plan for LMS, one of Seth's observations was, Alex, I get it. When you started your career, FPGAs were just prototype devices. Well, you know what? There are a lot more than that now, and we can do a lot more. And that really was a shot across my bow to get with the current opportunities and the current capabilities of FPGAs. And we both recognized that the network edge was both a huge limitation in what we were trying to do on the buy side or the sell side. And it also was an opportunity to innovate. It took Seth about a year to get me to leave my comfortable seat at Two Sigma. And January 1st, 2020, right before COVID, great timing, I joined the LMS team and haven't looked back.
So when did you actually join Two Sigma? Was that around 2011 or was that before that?
No, 2006.
2006. Oh, okay.
So I was there 14 years.
Yeah, so I wonder if I bumped into you back then when I was, well, about 2009, Miracom was selling NICs into HFT. And then SolarFlare started into that market around 2010, 2011. So that's probably where we started crossing paths.
Could very well have been. And in those first years, it was a wonderful environment where it was truly like a startup. The team was small. And, one thing I still use at LMS when I interview someone is to understand their character and their approach to life. I say, so you walk out of your office and you see a garbage can overflowing. What do? And as the CEO, I'm going to stop and pick it up and empty it out.
Right.
And if you're not comfortable doing that as a colleague, then we have an issue because startups do not have the resources. I've heard someone once say, don't we have someone who does that? Well, no. At a startup, you don't have someone to do the proverbial that.
It's everyone's job.
Exactly.
Right. No, I totally agree with you. If we take a look at LMS, how does LMS fit into the larger SmartNIC market? I mean, what offering do you have that's truly unique and different from what's out there today?
So to refer back to what I just said about defined terms, a lot of people talk about SmartNICs. And in fact, NVIDIA differentiates SuperNIC from SmartNIC, partially because they recognize the difference between a device that is truly programmable at the network edge and one that is configurable. So we're focused on a SmartNIC, and there is a gating technology that you need to have a true SmartNIC in our view. And that is you have to have all real-time message processing done on the NIC as the transceivers pass the bits to the Mac PCS. It's all on the NIC, because once you have that, you have the ability to pre-process, manipulate, and utilize the data right there and then with the lowest possible latency, highest reliability. Some folks will want to then take that data and maybe put a trading app right connected to it for the lowest possible latency. Others will want to pass just the message or perhaps the message with some headers across the PCIe bus into the user space. So a SmartNIC is an enabling technology, and the enabling piece of it is that the network stack exists in hardware, not pieces of it, all of the real-time processing. And I'm being careful here by saying the real-time processing. There are aspects of setting up a network connection that happen once per session, and there is no benefit on a per message basis from putting that in scarce silicon resources. So I'm totally comfortable looking at the network sessions and taking non-real-time aspects and putting them over in software.
So you've basically taken the session part of the TCP stack and moved it into the FPGA as kind of a TCP offload engine.
To be a little careful
Hmm.
because there are some aspects of state information that if you move into software either can increase the latency because, for instance, you've got an ACK and you have a message that wasn't received. So I'd say more session setup, and it's not just TCP offload, it's Ethernet, MAC PCS, Ethernet, UDP, TCP,
Sure.
and folks are familiar with TOEs, TCP offload engines. We would argue that is a necessary part of creating a SmartNIC, but it's not enough to really have all of the flexibility that a SmartNIC enables for pre-processing data on the card itself.
You guys essentially have the FPGA bit stream that goes and runs in the card, process packets, and so forth. But at a hardware level, I gather you rely on partnerships like Bitware and others to provide you with a hardware platform on which to run
That's
over NIC.
absolutely right. One of the things that we believe very strongly in is any company, but as a startup, it's really essential that we just focus on our core competency where we can differentiate. And a clear part of our business model is to put together partnerships to deliver the things we're no good at or have no competitive advantage by partnering with great global institutions. And I think, earlier when we spoke, you mentioned Bitware. They are both a great example of what we're looking for in the prototype for many of our partnerships. Bitware is a global entity with both design and manufacturing expertise. So since we don't have the board expertise and we're not going to add any value there, we were very excited to work with Bitware to say, here are the specs that we think financial services would want on a board, driven by the realization that PCIe slots are expensive. So let's get some density of interfaces on there. Our boards have 8 or 16 typically interfaces, but also let's put RAM on the board itself so that we have plenty of buffer for both the network stack and client manipulation. So Bitware is the prototype. As I said, at this point, we have partnerships with other firms. In general, you can think of LMS as an IP company focused on the FPGA network stack and related. At this point, we have over 19 patents. So that's where we differentiate. That's where we add value. Figuring out how to have a low noise physical network card with the BMC and the analog design. That's where Bitware comes in and gives us a stellar product to put our logic on. Now, to be clear, we're not in the business of licensing our IP to go wherever. We've identified real client problems and we're focused with our partners on delivering a holistic solution. So that actually is something Seth and I bonded over before actually I even joined, that we were often pitched by sometimes very bright technologists with their new technologies. And you sort of got the feeling that they had the technology in their hand and they were trying to shove it in our face and never stopped to say, well, what's your actual problem? And have I packaged this technology in a way that solves your real problem? We're absolutely focused on that. And that's another reason why we focused so much on creating the partner ecosystem so that we can deliver complete solutions that are really plug and play at the simplest.
Yeah, Craig and the boys at Bitware do an excellent job on the card development stuff. I did develop 2 cards with them while I was with Acronics, and their attention to detail is amazing. Now, when you mentioned moving a lot of the processing down into the FPGA, this kind of creates the environment where you can almost do network attached compute or NAC. How do you view network attached compute fitting into the whole Ubernic offering? And
Absolutely. We think NAC, or we like to say from NIC to NAC. When you start with a SmartNIC, you open up the opportunity for network attached compute. Obviously, you're not going to do very large processing, but in so many industries, let's jump from financial services for a second and look at AI. AI is all about processing an inordinate number of small messages quickly and directing them perhaps to the correct GPU. That is something that's perfect for a NAC. The message comes in across the fiber. You can extract the payload, you can manipulate it, you can direct it where it's best going, and that NAC functionality offloads substantial overhead from your server itself. Every time you have to send a message across the PCIe bus, compete for a CPU core simply to extract the payload and maybe say, okay, this came from XYZ source, so I'm going to treat it in a certain way. That all that overhead is trivially easy to do on the SmartNIC or the NAC. Examples of an appropriate use of a NAC would be a packet capture, time synchronization, even things like a data handler. Are you doing A/B data arbitrage? Are you normalizing your data? That is not compute intensive, but is very time sensitive and perfect for a NAC.
you mentioned that there are other applications for Ubernic beyond financial, like AI, and you wanted to take Ubernic more mainstream. Are there other markets beyond AI where you think this fits well?
When you look at the complete vision that we have for a SmartNIC, it's not just network processing, but it's also time stamping with down to picosecond accuracy. If you look at our White Rabbit implementation, there are many industries, streaming, telco, defense, cloud, that benefit from the integration of this trivial extra functionality onto the SmartNIC. Let me give you an example. It turns out that time synchronization is another one of those enabling capabilities for other industries. There's a great story that came out of CERN, which is why they created White Rabbit. So often these great technologies have great origin stories. And the origin story for White Rabbit is that the CERN scientists were trying to measure the speed that with which they could send, I believe, a neutrino from somewhere in Switzerland to somewhere in Italy. And lo and behold, they actually measured that the neutrino traveled faster than the speed of light. Einstein was wrong, but they stopped and said, no, this can't be. And what they really found out was they identified the limitations of their ability to synchronize time across long distances. And that was the nascence of this White Rabbit project. And today, working with CERN, we're able to synchronize time to under 20 picoseconds. Now, that's greater resolution than CPU and operating systems can handle today. I mean, right? Today, OSs understand nanoseconds, not picoseconds. So we half jokingly say, with the state of today's server hardware, we snap to the nearest nanosecond with picosecond resolution.
You've talked in the past about AI being a force multiplier. And, earlier this month, we learned from Microsoft that Copilot is now for entertainment use only because they've had the lawyers get involved. And I guess it's not as trustworthy as one might think. So in markets like financial, where making a decision is critical because If you make the wrong one, then clearly you could lose quite a bit of money in a transaction. How do you see AI fitting into that, and how do you see what you guys offer plugging into that portion of it?
So I totally agree with your premise to start with, Scott. I think the lawyers are in charge here. And whether it's parking your car in a garage or buying a ski ticket, the lawyers end up defining really crazy terms. Like, for a ski pass, it reads like you agree that you're an absolute moron for skiing and you'll almost certainly die. And that's only to address the legal liability. I'm not surprised Microsoft is doing that. We all understand that AI makes mistakes. It's at best as good as the source data that it has, and source data is often ambiguous. So for me, that is not a reason to say, well, AI is just for fun. It's use AI wisely. And I am a significant fan of the force multiplier concept, where AI can be used as a force multiplier. And that, in my understanding, comes from the military. And in the military concept of force multiplier, it doesn't mean that you are root and branch pulling out your troops and plugging in something else. It means two or four or five troops can accomplish what 10 or 20 could because you've given them this extra capability. And I see AI already having an impact in financial services. And let's also remember, when you're looking at a systematic house, a quantitative trading house, it's not about being right 100% of the time. In fact, it's about being right 50 plus epsilon percent of the time and having enough small bets to make things work. I actually earlier today was looking at a mock-up news sentiment portal that was built on top of an AI foundation. And it was just extraordinary what you could see quickly. It is an enabler and a force multiplier. It absolutely requires knowledge of what you have and validation.
Alex, what do you see as some of the challenges facing SmartNIC cards or, this class of cards as we go forward in the financial market?
SmartNICs are inherently programmable devices, and in our view, are inherently FPGA based. And it turns out, if you look at the number of engineers in the world and you say, what percent of them are software engineers? Huge percent. But if you then narrow it down to say, well, what percent of them understand how to program hardware in terms of an FPGA, RTL level logic, you're orders of magnitude fewer. And so it turns out that FPGA programming is challenging for folks. And if the value proposition is, hey, XYZ bank or exchange, in order to use a SmartNIC, you need to have all the in-house expertise to program the FPGA. You have to have a transition path from software to put things on the FPGA. The activation energy, I loved chemistry as a kid. The requirement, the energy needed to get your first benefit is just not realistic. And so one of the challenges is figuring out how to, I will say, insinuate a SmartNIC capability into an organization with the least overhead, the least requirement for changes, and then let the organization grow with their desire, their needs, and their capabilities. This is one reason why, I mentioned earlier in the interview, we're focused not just on the network stack, but what putting the network stack on the FPGA enables. And so I mentioned things like, well, we timestamp right at the Mac PCS. We do time synchronization, so you don't need a top of rack time box. We do packet capture. These are all benefits that are brought to the client because it's a SmartNIC. It doesn't matter to the client that we implemented it. They just want to know that, hey, I need a packet capture card. I need a time card. I need a data handler. All these things can benefit from the SmartNIC. But the way we've done it is it's just plug and play. You take your existing card or your existing BOM and you substitute Ubernic for whatever you were using. And day one, it effectively just works. You upload our library and it just works. Over time, some customers will want to put their own trading strategy. In fact, some clients already have FPGA experience and have their own trading algorithms on a bitware card, as an example. We can allow them to put that same logic, proprietary logic, confidentially, we don't see it, on the card, and they leverage our ongoing work in all of the capabilities that I described a minute ago, starting with the network stack. There are others that are filling up their servers and sometimes buying extra servers because they've run out of PCIe slots with single purpose cards, especially in financial services. We can all think of the number of expensive single purpose cards that we fill up a server for. And, the cost of the network card is truly irrelevant if, oh, shoot, in order to have the number of interfaces and to have the capability I want, I need a second server. Think about that CapEx and ongoing OpEx, simply perhaps to have a data handler or packet capture that pushes you over the limitations. And of course, in today's data centers, heat and energy is a big issue. And so by consolidating more functionality into a single card, thus into a single slot with, as low as 19 watts of power usage, that is incredibly efficient from a OpEx perspective.
Yeah, understandable. Heat and power are always the challenges when you're dealing with this class of card. Some cards, they try to get into the 75 watt envelope and run without external power. You see that on some of the FPGA based trading NICs on the higher end AI cards.
Mm-hmm.
The last card I did with Bitware was 350 watts, right, for an FPGA card.
And, you also need to keep in mind that a lot of the servers people are deploying, even if nominally they're PCIe 5 servers that can use that 75 watts per channel. Well, wait a minute. The server manufacturer may have put in a PCIe bridge that actually is only PCIe 4. And oh, wait a minute. Perhaps they can only divide up the 75 watt power budget across multiple PCIe cards. So you really do have to be cognizant of the whole environment you're fitting these devices into.
Right. You can't just assume, oh, I've got the slot to myself, so I've got all 75 watts and I'm good to go.
Exactly.
Right?
That creates a very unfortunate, ugly conversation sometimes when people realize they don't have all the power they thought they had.
As we move forward, there are a lot of exciting new developments coming up in this space. What things are you interested in or excited about to roll into your future products? Anything you can talk about, or is it too much on the roadmap that
so in general, our roadmap is confidential, but I will, seed a little something with the explosion of these data centers focusing on AI. You know what chip architecture they're using? It's not so much x86 anymore.
Right.
ARM is increasingly important. And of course, if you're an ASIC-based NIC, you've pretty much locked yourself into whatever chipset you were designed for. We definitely see ARM as an interesting market and need in the future. And stay tuned for what we have to say about ARM. I'll put it that way.
Yeah, I think we're going to see a lot of interesting things, as a result of the chiplet space growing. Mm-hmm. If you look at UA Link, that's about ultra accelerated link, which is a way to link chips to chips through a kind of an AI interface that competes with NVLink. There's going to be some interesting developments there. Fiber between chips directly. So I think there's a lot of
Now, to be
Photonics,
clear,
silicon photonics is the term for it, yeah.
right. So that's at a higher throughput level than we're targeting. Our expertise is more electrons than photons. And for us, our cards go up to 600 gigabit Ethernet, again, lossless, very important. But, there are those folks who want to go 1 to terabit and beyond. And that's not who we are. That's not our expertise. Back to how I started. We're trying to be really rigorous that know where we have a competitive advantage and we have strengths, and we're leaning into that.
So if we were to look out, 5 years, do you guys have, a long-term vision of where you see things going?
So we really think that the market for SmartNICs and enterprises, we're not talking consumer grade anything, but for enterprises, any firm whose business is directly correlated to the amount of data they can move reliably and accurately or efficiently, for those, SmartNICs are the solution, and we believe we already have the leading SmartNIC, but we want to dominate that space across industries, not just in financial services, and partner with folks who have industry-specific IP that will sit next to our network stack. I mentioned at the beginning of the call, this network stack on an FPGA is an enabling technology. I also mentioned we like to stick close to what we know. You can imagine that there are a lot of value add processes that other firms have already created, and we're happy to work with them to incorporate them on our NICs. So ultimately, we don't do everything, but we enable everything on the network edge.
Excellent.
So this is a really exciting time for the markets. And I'll give you an example. There was a quote about AI that, the often overlooked secret is that it's the network edge that is the biggest constraint to AI compute. And imagine, these data centers that people are spending billions to seemingly trillions of dollars to build, NVIDIA being the largest recipient of value by delivering their GPUs there. I recently read that up to 30% of GPU time can be idle waiting for data. So what does that say? If you can move data quicker and locally, and I'll call that composable I/O, you can dramatically increase the value of these data center investments. And that's precisely where we feel we have a strength and differentiate.
Okay, composable I/O. We've heard that term in the past, but it hasn't surfaced lately. So it'll be interesting to see how that goes.
Yeah, well, I mean, we actually were the first firm, as far as I know, to put CXL on a general purpose NIC. CXL is still going through its teething pains, but it's reflective of our priority in having a flexible composable I/O layer as we grow, and certainly as we grow outside of financial services.
Yeah, it'll be interesting to see how you use CXL moving forward, right? Because that theoretically could allow, your NIC to talk to a GPU directly over the PCIe bus without having to get the host CPU involved.
Exactly. And not just that, think about the streaming world, validating a customer in a stream and directing its path is not rocket science, but you want to do it really fast. And cutting out the server part of that equation is definitely a way to improve the user experience while lowering CapEx and OpEx.
Excellent. Well, thank you for your time today, Alex. It's been very illuminating. I enjoyed the discussion greatly. It was a pleasure having you.
Thank you very much, Scott. I enjoyed, well, obviously we love this stuff and we're living it, but I appreciate the opportunity to talk about not just our product, but what we see as the market needs and how it's evolving. So pleasure to speak with you today.
Thanks everybody for listening to SmartNICs today. Tune into the future episodes. Have a great day.